Welcome to you all. Hope that this session will give you a base and basics about project network diagram. Network Analysis Part 1 and Introductory Note. Presented by Dr. Somathambi Senthilnathan. Abstract. This presentation basically provides insights about drawing a network diagram. In addition, it is also useful to know and understand the birth and meaning of a network analysis, its importance, applications, limitations, rules and traditions in drawing a network diagram, and the terminologies used in relation to network. Introduction. The network analysis is one of the important quantitative techniques in the process of effective management decision-making process. This management technique is utilized in management science and other business-related operations such as project management, operations management, systems development, software engineering, research and development, etc. Its application and contribution are very much significant and ever usable anywhere and anytime. This is one of the techniques that should be well learned by managers and decision-makers in an organization. This technique significantly contributes to any sector based on its requirement to have an implementation plan and its utilization of limited resources towards achieving its objectives effectively and efficiently. It helps an organization mainly to facilitate in designing, activating, and implementing a project within a time span. This network analysis determines in advance the normal duration and cost, as well as minimum duration and minimum cost of a project to be implemented. Importantly, this technique helps managing risks and waste, and determining in advance possible implementation of events and activities in a project. It is also difficult to complete massive scaled projects without having network analysis, since such projects employ large amount of financial, human, physical, and other resources at an optimum level. Further, as they have alternative utilizations, network analysis becomes essential for determining and managing their mobilization within projects. Hence, the application of network analysis is useful to facilitate planning and implementing management activities, allocating resources for their optimum utilizations, and defining, designing, and completing activities within stipulated time frames. This technique integrates basic time factors, resources, costs, and probabilities of events. Hence, there are a few relevant software that have been created as the results of realizing the importance of this technique in project implementations. In general, different terminologies are used to indicate this technique. They are namely critical path planning, critical path analysis, CPA, critical path scheduling, critical path method, CPM, and program evaluation and review technique. However, it is precisely notable in network analysis that critical path approach, CPA, and program evaluation and review technique, PERT, are critically viewed as two different aspects. Next is the definition of network analysis. Lucy, 1988, defines network analysis as a technique for planning and controlling of projects in view of facilitating the management of an organization. Lucy, 1988, indicates that while these techniques show the relationships among functions and activities, they are useful to identify critically and clearly each section and to provide information in terms of activities and their respective, individual time, cost and resource requirement in a project. A network analysis for a project plays a critically important role when the project consists of following identical features. A. Complexity of the project. This is possible when the project consists of many activities, which are much dependent on other activities. B. Large-scale projects. It refers to the project that requires many facilities, large amount of capital and labor density. And C. A large number of restrictions. This happens when the project needs to be completed within a time frame and cost limit that are related to utilizing the resources of raw material and labor, partially or as a whole. Now, we can see what are the applications of network analysis. In general, the applications of network analysis considerably take place in project management. Its application appears to be effective in other areas such as manufacturing industries, marketing, telecommunication, large-scale building projects, transport, inclusive of building ships and aircrafts, computing and system design, and social service development. In these sectors, in relation to a project, network analysis significantly contributes to manage effectively and efficiently the project's completing duration, resource utilization, and resource-related cost control. It also critically facilitates devising and implementing appropriate controlling process mostly in accordance with the project duration. The next is the advantages of network analysis. Firstly, facilitating management and individuals in the tasks and process of project planning, implementation, and controlling. Secondly, resolving management-related issues and problems on a project, when the project appears to be in complexity and large in scale, consists of many constraints and needs to be completed in a specific time frame. Third, contributing effectively to an organization in the processes of planning, designing, implementing and completing projects in accordance with the resources available and with their respective costs. Fourth, maintaining and functioning with the relationship of activities with their preceding activities in a project. Fifth, facilitating implementation of projects effectively and efficiently and provide room for practicing various stages of project management successfully. Sixth, very simplest in quantitative approach. And next, facilitating documentation appropriately in relation to project implementation. However, there are also some limitations of network analysis. They are: it requires clearly defined, independent, and stabilized activities in a project. It considers only preceding activity, or activities, of an activity in a project network formulation. It pays a crucial attention to critical path or critical activities of the project. Next, it is important to know about the basic terminologies in network analysis. In this context, firstly, an event. An event is a point where an activity begins or ends, and therefore, it indicates beginning or completing an activity. An event is normally shown by a circle in a network diagram. It is custom to draw an activity by an arrow in a network diagram, and every activity has two events, namely, tail event and head event. The event at the beginning of an activity is called tail event, and the event at the end of the activity is called head event. Note that an activity by an arrow places itself both tail and head events for the activity because the activity itself consists of tail event at its commencement, it is known as the starting point, and head event at its completion, it is known as its ending point. Secondly, when a project is broken into many identical parts or tasks, which are independent in completion, a single part or task is known as an activity. An activity represents its importance in a project to be completed within a particular time span and requires sufficient resources for its completion. For an example, if it is intended to build a wall or to dig for putting up a foundation for a building, the time required to complete a particular activity is known as its completion duration. Generally, there are many identical activities in a project. These activities should be arranged in a sequential order of completion, based on their individual dependency on preceding activity or activities. However, There is no preceding activity for beginning activity or beginning activities in a project. For the following activities, there can be one or more preceding activity or activities, that is, the activities other than the initial activity or activities can be dependent on other activity or activities for their individual completion. There are two general approaches to draw a network diagram of a project that consists of different and identical activities. One is activity on arrow diagram, and second is activity on node diagram. In the activity on arrow network diagram, it is customary to show an activity with an arrow. The head of the arrow indicates where the activity ends or completes, and the tail of the arrow indicates the beginning of the activity. See how an arrow is shown with start or tail and finish or head points. Note that it is not necessary to draw an arrow representing an activity, from left to right, with a specific scale/unit of duration. In a project, an activity can depend on other activities/activities for its commencement. When drawing such dependent activities in a network diagram of the project, the events are used to connect and differentiate those activities. See the given network diagram, which is activity on arrow, where the letters A, B, C, D, E, F, and G represent related 7 activities of a project. In the given network diagram, you can also note that the activities A, B, C, D, E, F, and G are connected with the events, numbered from 1 to 6. See the given network diagram of activity on node. In the diagram, an activity is represented with the shape of a rectangle. It is notable that the project network of activities on nodes have to be placed between additional 2 start and finish nodes, and the rectangles representing activities A, B, C, D, E, F, and G are connected with the arrows. It can be mentioned that the network diagram of activity on node is similar to the network of activity on arrow. This can be observed by comparing both diagrams with the information in the given table. It is important to know certain key aspects of having a network analysis with a set of activities identified in a project. First, it is necessary to define uniquely identifiable activities in a project. These activities should be individually independent of their completions from start to finish. These activities must be identified and organized with their sequence of logical relationship. In relation to every activity in the project, its completion duration, resources required, and cost to be incurred must be determined. Considering the above aspects, one can organize basic initial steps to draw a network diagram for a project. It is notable that the usual method of representing an activity on arrow is consistently used throughout this explanation, since most of the textbooks in quantitative techniques and analysis, management science, and operational research apply the same for illustrating network analysis. The next term to know is about a dummy activity. This is an activity that requires no time, resource, and cost to incur. However, this dummy activity is used to maintain logical relationship of other activities in a project, and avoid violation in drawing its network diagram of activity on arrow with rules and procedures. It is a usual practice to show a dummy activity with a dot arrow, as shown here, in a network of activity on arrow diagram. This can be shown with the following information of an example. For the information in the above table, the network diagram is drawn as shown here. In the diagram, activities A and B begin from event 0. According to the network drawing customs and procedures, as shown below, these two activities cannot end at the same head event as they begin at the same tail event, namely 0. Therefore, they should end at two different events 1 and 2 respectively, though they begin from event 0. It is also given that in order to commence activity C, the activities A and B must have been completed. As given in the information table, it is notable that, firstly, commencement of activity D need only activity A as being completed, not activity B, and secondly, activity C commences after completing activities A and B, as a dummy activity is drawn from event 1 to event 2. It is notable that drawing a dummy activity from event 2 to event 1 cannot satisfy the requirement of activity D, that is, requiring activity A only is being completed, not activity B. The next term is network. It is a diagram that has been drawn for a project with its logical sequence of relevant activities, dummy activities and events, in accordance with the network drawing procedures and traditions. In this context, the relevant procedures and traditions used and applied to present a project network are explained next. Next is the procedures for drawing a network. A complete network diagram must have a starting event and a finishing event. Referring to the network diagram below, the project consists of starting event 0 and finishing event 3. Every activity must have a tail event and a head event, where many activities can have a tail event or a head event, like activities A and B above. Similarly, the different activities from different tail events may end up with a head event, like activities C and D above. The next procedure is the activities having a tail event must not end at the same head event. You can see it and compare the diagrams given. When required, a dummy activity is used to facilitate this limitation. In this context, compare the images presented here. In right image, the tail event is the same for activities A and B, and the commencement of other activity depends on the completion of activities A and B that will begin from event 2, as the dummy ends at event 2. It is notable in the image on right that the activities A and B are linked with a dummy activity, and then the commencement of activity C is shown accordingly. The activities that come from different tail events can end up with a head event. In the image given, see that activities A, B, and C respectively begin from events 6, 4, and 5, and they end up at event 7. Also, before an activity is to reach its head event, no new activity can start from that head event. A tail event that carries many activities cannot be considered as a complete event until those activities individually reach completion. Activities and events cannot be linked like a loop or form loops as there is no beginning and ending. The image, with the formation of a loop, fails to represent a starting point and a finishing point as well. All the activities of a project must contribute to complete the project. Therefore, all of them need to be connected with their sequential logical order and relationship in the project network. This indicates that no activity can dangle as left and separated as not contributing to the completion of the project. This type of dangling activity, like C in the given image, is not permitted in a network of the project. Next is the traditions in drawing a network diagram. Beyond certain procedures set above, there are certain traditions followed in drawing a network of a project. First, a network diagram needs to be placed with events and activities from left to right or top to bottom, up down. Second, a network diagram needs no scale for activities. The sizes of events and activities can be drawn as convenient as possible. Third, it is not necessary to have arrows that represent activities horizontally. However, it is better to confirm the direction of arrows from left to right or up-down approach, where necessary. Fourth, it is not necessary to have the arrows like straight lines. They can be drawn as curvilinear or kinked curves as consistent with the above tradition in 3. Fifth, the numbering of events needs to be made in a sequentially arranged order. Sixth, it is wise to apply capital letters or numbers to represent activities of a project. Seventh, it is reasonably better to avoid intersections of activities in a network of a project. 8. It is also very good to have network diagram with a minimum number of dummy activities. Now, it is possible to move with the first example to make clear about the above said aspects and customs applied in drawing a network diagram of a project. To apply the above said about network analysis, the following information is available with respect to a project. In the information, it is identical that the project has been broken into 13 activities, which are namely from A to H, 8 activities, and J to N, 5 activities. Also, their respective preceding activity, or activities are also available. This is the step-by-step process of creating the project network based on the information available. Activities A and B are the initial activities since they have no preceding activity. Hence, they begin from initial, 0 event. Other activities from C to G have been drawn based on their preceding activity. Here, other activities H and J have been drawn based on their preceding activity. As activity J requires the completion of activities B and D, activity D is adjusted to meet the requirement. Note that activity H with preceding activity C is repeated in the table. It is a mistake in recording, and please neglect it. Subsequently, activities K and L have been drawn based on their preceding activities. It is notable that activities H and G have the same tail event 3. Hence, event 5 is put to merge completion of activities E and H, and event 6 is set to complete activities G and K, and then, a dummy activity is created to start L. As a next step, activities M and N have been drawn based on their preceding activities. Thus, the network completes with the activity N, which ends at event 8. It is possible to note that the dummy activity created meets all necessary requirements. In this context, it is important to check twice with the information available to confirm every activity is in order, including dummy activity. This is the finally structured network diagram representing all of the activities and events of the project with their respective preceding activities in order. Now, it is time to consider another example with the activities of a project that are not sequentially presented in the order of completion. It is required that the order of completing activities should be sequential. If not so, they must be organized into their sequential order of completion to draw the network. This example too is related to this context. The activities from A to F of a project are given with their preceding activities. However, they are not presented with their completing order based on their preceding activities. It is notable that the information in the table is given in the alphabetical order of the project activities. They must be reorganized based on the precedings. For setting up the sequential order, as a first step, the reorganization of activities should begin with the activities with preceding activity as shown here. The first selection of activities should be the activities that have no preceding activity. In this context, activities D and F have no preceding. Hence, they are considered first in the completion order as shown here. As a next step, organize the activity that has D and/or F as the preceding activity as shown below. As activity D becomes preceding activity to A, first place activity D in the preceding activity column and then put its corresponding activity A in the project activity column, as shown in the process. It is notable that activities are arranged with their logical sequence of completion, where activity D is identified as not having a preceding activity and becomes a preceding to activity A, thus the arrangement is made accordingly. As the next step, organize the activity that has D, F and/or A as the preceding activity or activities. It is identical that activities D and F become preceding activities to activity E. Hence, preceding activities D and F are placed in the preceding column and their corresponding next level completing activity E is presented in the project activity column, as shown in the process. As previously done, in the same way, the rest of the activities needs to be organized, as shown below for activities C and B. Accordingly, activity A becomes preceding activity to complete activity C, and activity E becomes preceding activity to complete activity B. Hence, now, all the activities are well organized in their order of completion with their identical preceding. At this point now, it is possible to see, firstly, all provided activity information in the first table. Secondly, reorganization of the activities in the next table to draw the project network diagram, and finally, the drawn diagram for the project, at a glance in order. Now, it is time to test yourself whether you are confident enough to answer the given questions. First, what is network analysis? Second, differentiate an activity and an event. Third, what are the basic aspects to be followed in drawing a network? Fourth, what is a dummy activity? What is its importance? Fifth, differentiate two different approaches of drawing a network. If you are confident enough to answer these questions, you are almost ready to move on to the next level of learning the network analysis. Good luck with your learning. This is for your question and suggestion time. If you have a question, please post it in the comments section. Hope that you would have enjoyed and benefited with this presentation. If you have words about this presentation, you are so much welcome to have your say to improve my next presentation. I would appreciate your valuable comments as feedbacks for the same. Thank you guys, with the expectations of your valuable and meaningful comments.